Hello and welcome everyone to your week 7 lecture on bone health. Right, so you do have a couple of pre-readings as always, so please go through those and remember that your pre-readings are included as part of your exams and assessment because I'm not giving any research papers to read, but they are just part of your PowerPoint slides. So yes, they are included as part of your mid and final exams. So now we go on to the main content and I'll start from here. So the first thing is calcium homeostasis. So what does the term homeostasis mean? It means maintaining adequate amount of blood calcium level. So guys, the biggest, one of the most important theories as part of your body is that your body tries to maintain as much as possible all nutrient levels in your blood, because your blood is the only fluid which can travel everywhere in your body. So your liver is stuck at one place, your stomach is stuck at one place, they can't travel anywhere, right? But your blood is the only one which can travel all across through your body, and it carries oxygen and it carries nutrients. So basically it carries all of the vital sources which are needed for the survival of your other organs. All right, so therefore the main principle of the body is to maintain nutrient levels in the blood as much as possible, and the same goes for calcium. Your bone health will be compromised to maintain your blood calcium level. This is how important blood calcium levels are. All right, so yes, your bone contains 99% of the calcium in the body, and calcium homeostasis means maintaining your blood calcium level within the 8.5 to 10 milligram per deciliter range. All right, so now there are two important hormones which are involved in the regulation of blood calcium level, meaning when your blood calcium level goes down, two important mechanisms are involved in this to maintain or to increase your blood calcium level and to bring it back to normal. First one is the parathyroid hormone mechanism, and the second one is the vitamin D mechanism. So now the active form of vitamin D is called as vitamin D3 or calcitriol or 125 dihydroxycholecalciferol. All right, so yes, all of these are different names for vitamin D. All right, so now you have two mechanisms which are involved in calcium regulation. The first one is your endocrine mechanism and your osteoclastogenesis mechanism. All right, so your endocrine mechanism predominantly has to do with your two hormones, your parathyroid hormone and vitamin D3, and your osteoclastogenesis mechanism has predominantly to do with the parathyroid hormone. So you will see the details of it. All right, so before we go on to the mechanisms, the first things first, which is your vitamin D biosynthesis in the body. Okay, so when, as you know, that sunlight is the biggest source for, say, activating your vitamin D in the body. So from sunlight, what is activated or what is triggered is your 7-dehydrocholesterol. All right, now the 7-dehydrocholesterol is the one which gets converted to cholecalciferol, which is vitamin D3. All right, it is not the active vitamin D3. It is still going to happen in the future, like in these steps. All right, so yes, your sunlight is, when we say, is the biggest source of, say, vitamin D, it is because your sunlight helps in the conversion of 7-dehydrocholesterol to cholecalciferol. This cholecalciferol goes to the liver, and then you have little bit source of vitamin D even from your dietary intake, like your fish, meat, D3, which is the animal sources, even a bit from milk, very minuscule amounts. Then D2 from fungi and plants like mushroom and things. All right, so yes, you have very minuscule sources of vitamin D3, vitamin D coming from dietary sources. Predominantly, the vitamin D3 is, say, activated via the sunlight. All right, so now you have this vitamin D go to your liver. Liver is the first site for activation of vitamin D. This is also called as hydroxylation of vitamin D, which happens on the 25th carbon atom. All right, then this 25 hydroxy vitamin D3 or 25 hydroxycholecalciferol, this goes to your kidney, and then it is activated on the first carbon atom, or it is hydroxylated on the first carbon atom. This is where you get your active vitamin D3, or else it is called as 125 dihydroxycholecalciferol, or else the same thing is called as calcitriol. All right, so this is basically the process of activating your vitamin D in the body. All right, so I hope this is simple. Okay, so now you have your first mechanism, and the hormone which is predominantly involved are both of the hormones which we briefly spoke about, parathyroid and vitamin D. Right, because vitamin D has such regulatory functions in the body, guys. Therefore, vitamin D is called as, say, a regulatory hormone. It is one of the only nutrient. Okay, so you have vitamin A, but we don't call vitamin A as a hormone, right? We call vitamin D as a hormone because it has such regulatory functions. And if you remember your mental health, you know how vitamin D had an immunoregulatory function at that space. So basically, yes, that's why we call vitamin D as a hormone, because it can actually change things and do such things in the body, which is, say, activate something, deactivate something, trigger something for synthesis. So it has a very hormonal sort of a function. All right, so now coming back to the point, guys. So you have your endocrine mechanism. All right, this is the first mechanism. So now remember, this happens when you have low blood calcium level, and remember the rule of your body, homeostasis, which is it's okay to compromise your bone health, but you need to maintain your blood calcium level, because guys, when your blood calcium level is low, you have a lot of, say, calcium channel blockers and things like that, which regulate the gateway of what enters the cell, what goes outside the cells, things like that. So this can create a lot of, say, problems at a neurological level, at a cardiac level, so on and so forth. But I won't go into each and every functioning of, say, calcium, because that is again very food science. All right, so now coming to the pathophysiology. So here, when you have low blood calcium level, this is sensed by your parathyroid gland. Okay, so your parathyroid gland is in your, say, neck area. Okay, so your parathyroid gland senses that the blood calcium level is low. Therefore, it secretes parathyroid hormone. So now, because of low blood calcium level, you have high parathyroid hormone in your blood. All right, this high parathyroid hormone tells active vitamin D3, all right, which is calcitriol, to increase calcium absorption from the kidney. All right, so now the absorption of calcium is directly proportional to the need, meaning when you have low blood calcium and you need more calcium, you have more absorption of calcium from the kidney, meaning from what you have eaten. Okay, so yes, vitamin D, it increases the absorption of calcium from the intestine into the blood. Okay, so this is one way of increasing your blood calcium level. Second thing what vitamin D does is that it decreases the excretion of calcium from the urine. Okay, this is called as reabsorption of calcium from the kidney. So it is not thrown out in the urine, because you want to increase your blood calcium level. Now, always remember, calcium and phosphate, they are opposite in nature. Just like how you had sodium, potassium opposite in nature. All right, similarly, you have calcium and phosphate or phosphorus, which is opposite in nature. All right, so now what happens when you have increase in calcium retention in the body, you have increase in, say, phosphate excretion. All right, so phosphate excretion increases, calcium retention increases. All right, so now this is the second way of increasing your blood calcium level. Now, the third way of increasing your blood calcium level is increasing bone resorption. Okay, now there are three terms over here. First, you start with absorption, then reabsorption, then resorption. What is resorption? Where your bones will be demineralized, meaning your calcium from the bone is released into the blood to increase the blood calcium level. So yes, you have demineralization of bones happening. Your bone health is compromised because the body does not want to compromise the blood calcium level. Otherwise, as I said, it can cause a lot of major problems. All right. So for those major problems, you need to know the functions of calcium, basically. All right. So guys, this is the pathophysiological mechanism behind the nutrient and the condition, which is, say, decalcification of bone. All right, so all of these three together will increase your blood calcium level. All right, so it is a pretty simple mechanism. It's pretty straightforward. Once you have learned the diabetes mechanism, everything else is easy. Okay, so now guys, going to your second mechanism, which is osteoclastogenesis. All right, so now what is happening in this mechanism? Again, you have a role of parathyroid hormone. So the first thing is that your blood calcium level is low. Your parathyroid gland senses it. It releases parathyroid hormone. When you have parathyroid hormone in the blood, now parathyroid hormone attaches to a bone cell which is called as osteoblast. So now when you do the pre-readings, you will know what is osteoclast, osteoblast, these kind of bone cells. All right, so yes, now your parathyroid hormone, it attaches to osteoblast. All right, now this, what does this do? This triggers the connection between osteoclastic precursors and your osteoblast. Okay, and these connections are very important, guys. So please look at my mouse and see where it is hovering. All right, so you have the osteoclastic precursor. On the osteoclastic precursor, you have the rank, okay, RANK rank. Okay, so what is RANK rank? It is receptor activator of nuclear kappa B. All right, so that is the full name of it. All right, so you have your rank. All right, now this rank attaches to the rank L. So what is rank L? And this rank L, as you can see, it is present on the osteoblast. All right, so your rank L is receptor activator of nuclear factor B kappa ligand. So that is the L which stands for. So that pointy thing is ligand. And then you have the osteoclastic precursor where you have the rank. It attaches to that pointy thing. Okay. So now what is happening? Now this basically, it helps in the conversion of osteoclastic precursor to osteoclast. Okay, the difference between osteoclastic precursor and osteoclast is that osteoclast has multiple nucleus. So you see over here 3 nucleus, it looks like a mini alien. All right, but if you see the osteoclastic precursor, it just has 1 nucleus, normal looking cell. This looks like an alien cell, but this is there in our body. Okay, so now this osteoclast, guys, this is the one which increases bone resorption, meaning release of calcium from the bone into the blood. All right. And once when you have sufficient calcium level in the blood and you do not need any more bone resorption, then you put a cap on the rank L. Okay. So that cap is called as osteoproteogerin. All right. So that is what is the cap called. And once you have the cap, then you have no more, say, calcium resorption happening from the bone. Okay. So now this is your second mechanism. And yes, these are the only mechanisms for this lecture. All right. So yes, I've been good and not giving you more mechanisms. Okay. So now we look at 2 important bone conditions, guys. One is osteomalacia. The second one is osteoporosis. All right. So now in osteomalacia in layman terms, it is called as soft bones. All right. And predominantly it is because of vitamin D deficiency. Now, guys, osteomalacia under the microscope, it looks very similar to a healthy bone. Okay, so healthy bone will also look like this. But basically the mineral content of osteomalacia, bone suffering from osteomalacia is low. So the mineral content is low, meaning the calcium content in this bone is low. You have your calcium and phosphorus hydroxyapatite crystals. So the phosphorus content is low. All right. So basically the mineral content of this bone is low. Therefore, these bones are termed in layman terms as soft bones. Okay. Because they don't have enough of mineral. They are like rubber. Okay. They are easy to bend, easy to break. Think of it like that. Now, osteoporosis is when you have thin bones. The mineral content of the bone, guys, is not suffering. Okay, so the mineral content is all right. Okay, so if the bone should be, say, 99% mineralized, all right, so osteoporosis, bone is 99% mineralized. But the bone mass decreases. When the mass decreases, you have thin bones in layman terms. Okay, meaning the bone structure at a microscopic level, it's becoming thinner and thinner. Okay, so that's why you have these holes, these gaps which you see. Okay, so the bone mass decreases, osteoporosis, the bone mineral content decreases, osteomalacia, and osteoporosis is predominantly because of low calcium intake. All right, so now this is, guys, the main difference which I wanted to show you over here. So osteomalacia is this column, osteoporosis is this column. Okay, so now with osteoporosis, as I said, decrease in bone mass, malacia, decrease in bone mineral content. Predominantly osteoporosis because of lack of calcium, osteomalacia because of lack of vitamin D. And osteomalacia at an epidemiological level is predominantly seen in developing countries, especially in conservative backgrounds where individual may not be exposing themselves to a lot of sunlight because of the conservative clothing that they may be wearing, or else when, say, for example, in certain cultural group, ethnic group, women are not allowed to go outside. Children, especially female child, is not allowed to go outside and things like that. So when they're not exposed a lot to the sunlight, that is when you see osteomalacia. So seen a lot in developing countries, seen a lot in ethnic backgrounds, osteomalacia. Okay, so now the radiographic findings, meaning the say fracture sort of findings, you have osteopenia fractures over here, and you have P pseudo fractures. So see, now we are not radiologists. You don't need to know exactly how these fractures will look, say like at a microscopic level, but P pseudo fractures or loser zone fracture is basically hairline fracture. Okay, so you have these hairline fractures over here, and you have osteopenic fractures over here. Okay, you just need to know the terminology. As I said, you're not studying radiology to know how they exactly look under the microscope and things like that. So now guys, in your osteoporosis, when we talk about calcium phosphate level, parathyroid level, and alkaline phosphatase level, this is all referring to the blood. Okay, so in osteoporosis, this might as well everything be normal. Okay, and just with a simple blood test, you cannot know whether the individual has osteoporosis or not. Basically, for osteoporosis and osteomalacia, blood tests are not very reliable. Okay, similarly, it goes for osteomalacia, where the levels may be low or normal. There is no, say, one school of thought to it. Okay, most commonly what has been seen in osteomalacia is that alkaline phosphatase level is high. So alkaline phosphatase, guys, is an enzyme. So now what is happening in normal body, like you and me, who do not have any vitamin D deficiency, we know vitamin D helps in the absorption of calcium from the intestine into the blood. Now, once the calcium reaches the blood, you have alkaline phosphatase, which plays also a very big role in taking this calcium from the blood and taking it to the bones. All right. So this migration from the blood to the bone is done with the help of alkaline phosphatase. All right. So alkaline phosphatase is very high because it really wants to grab as much as calcium possible in the blood and send it into the bone, because the bone, as you know, they are demineralized, they are very soft, they need the calcium. But what can you do when the first step, which is getting the calcium from the intestine to the blood, is compromised because you have less vitamin D? All right. So do you see the first step is compromised? So even though alkaline phosphatase is very high, it is not very beneficial because there is not much calcium in the blood to begin with to take it to the bone. All right. So yes, guys, basically this is the difference between osteoporosis and osteomalacia. Okay, and guys, when you have osteomalacia in children, this is called as rickets. And generally, rickets are, say, in the shape of boat legs because they are soft bones, as I said. Okay, so they may be concave or convex in shape. This is called as boat-shaped leg rickets. And you may have obviously learned about this when you are learning about functions and deficiencies of calcium in general as part of your food science. You may have also heard of pigeon breast, because again, the sternum, it bends because of the same reason when you have soft bones, demineralized bones. All right. So yes, guys, this is an FYI. And yes, I'm sure you would have learned this in food science. Okay. So now, guys, with osteoporosis, one of the classic symptoms is the dogward's hump. So what is the dogward's hump? You may have generally noticed that with, say, age, the height of the individual may sort of decrease with a couple of inches. Okay. This is because the bone mass is weak now. The bones have become thinner in osteoporosis, and it is very difficult for the bones to hold up your structure how it can hold up, say, in the youth. All right. So that is why you have, say, the hump, the dogward's hump, and that is predominantly a classic sign which you see in osteoporosis. Okay. All right, guys, this is again just an FYI for you, which are what are the risk factors for, say, osteoporosis and osteomalacia. So this is just say classifying it based on a review which was published. All right, so high risk factors are things such as aging. Moderate are, say gender, like, say, for example, female, smoking. All right, and then no risk could be, say, or very, very minimal risk possible could be from, say, caffeine and tannin. No risk should be, say, termed as minimal risk, because 8% is still a risk. Okay, it is minimal, but it is still a risk. All right, so yeah, guys, this is just an FYI as to what are the risk factors for osteoporosis and osteomalacia. Okay, guys, again, the gold standard for measuring your bone mineral content, your bone mass content is your DEXA, all right? And you know, DEXA is also the gold standard for measuring your body fat percentage, okay? So yes, DEXA is a gold standard for bone mineral density as well. And guys, the results which the DEXA gives, they are in terms of your Z scores, all right? And these are the WHO criteria for Z scores. Now, if you see osteopenia, guys, osteopenia is the term which is used when you are at risk of having osteoporosis. Okay, so if you are, say, if you know of, say, your, say, mother, grandmother, father, etc., who may be having, say, osteopenia in their, say, results, DEXA results, meaning they are at risk of developing, say, osteoporosis in the future. All right, so good amount of dietary management, very important at this stage, all right, to increase their calcium intake. And also this is complemented with physical exercise. Why? Because physical exercise, it increases calcium absorption, all right, it increases calcium say retention in the bones as well. Okay, all right, guys, now you have key nutrients and what are their role in bone health. All right, so now the protein. Now, guys, your bone matrix is 30% of your, say 30% of your bone is compromised of your bone matrix. And these are nothing but collagen fiber, and collagen is nothing but protein. So when I mean by collagen fiber, this is the, this is the collagen fiber, guys. Okay, so this fiber mesh looking thing. So this is essentially protein. This web-like structure is protein. And then you add calcium and phosphorus to it, and you calcify the web. All right, so the web becomes hard and strong. Okay, but to begin with, the organic nature of your bone is protein in nature. Like, you know, how I just said in the last lecture with the undernutrition lecture, that we are essentially but protein. All right, so this is what I'm talking about. Even your bone essentially is protein to begin with. Okay, then now what happens that for example with protein, basically protein helps with calcium absorption. Why? Because basically when protein is broken down into amino acid, an acidic environment, amino acid, okay, an acidic environment, it favors the absorption of calcium, all right, from the say from the food. Okay, so it extracts as much calcium as possible from the food. All right, so it promotes calcium absorption, all right, from the diet which you eat. All right, so now guys, an important thing, this is a theory, it is still not clear, but what has been proposed is that very high level of protein intake, okay, which is say 4 to 5 grams, 4 to 5 grams per kg body weight, all right, this may increase the acidic load of your kidney, and therefore this may increase the urinary calcium excretion, all right. So now guys, this, as I said, is a theory. There is no 100% evidence. But yes, if a layman who is, say, not utilizing a lot of protein, but is just going to be eating a lot of protein, this will very highly likely increase the urinary calcium excretion because it increases the renal acidic load. All right. So now, guys, in terms of plant versus animal protein, again, this is just a theory. It is not clear. It is proposed that plant protein, it has a less renal calcium load, it has a less acidic load, and therefore this may prevent the excessive excretion of calcium from the urine, and therefore it favors your bone health. Okay, plant protein. Whereas animal protein, it increases the renal, say urinary, the renal acidic load of the body. All right, and therefore this may say increase calcium excretion in the urine. All right, so these are theories which have been proposed, but still not a lot of research to prove that yes, this is level 1 evidence. That is not there. Okay, then you have calcium. Obviously, you know, calcium is very important for your bones. So your bones, as I said, 70% is your hydroxyapatite crystals, which is your calcium, and your phosphorus crystals. Okay, so these two in combination, they make the bone hard and strong. All right, now calcium is one of the best nutrient which is very easy to meet from a balanced diet because calcium has very high bioavailability from foods which are rich in calcium. Okay, so for example, your dairy products, yes, they are legit rich in calcium, so you will be having a good absorption. Now, if you say like those random nutritionists which do not really have a good nutrition background, that have kale. Kale is very high in calcium and it is good for your bones. That is ridiculous. Okay, why? Because kales, you will see your veggies have something called as oxalates, and which decreases calcium absorption. So they are not rich bioavailable sources of calcium. There is a difference between being a rich source of calcium versus being bioavailable. Okay, so yes, kale is rich in calcium, but it has less bioavailability because of oxalates. All right, so but dairy, it has good bioavailability. Why? Because calcium is easily available from dairy. There are no oxalates and things to prevent it. Furthermore, dairy is such a beautifully engineered product by nature that your dairy, for example, milk, is rich in protein, it is rich in calcium. And you know that protein will be broken down to amino acid, and the acidic environment favors calcium absorption. So you see how automatically milk helps with calcium absorption because of the protein. All right, so yes, bioavailability, good from, you have your natural dairy products and things. Then calcium fortified products, they would fortify it in such a way that you have X number of, say, calcium milligrams met via drinking that serve of milk, which the industry is recommending. Okay, so yes, for example, if they say 1 cup of milk will say give you 60% of your RDA, they will be fortifying the soy milk or the oat milk or the almond milk in such a way that you at the end do meet 60% of your RDA. Okay, so I hope that helps. So yes, guys, with non-dairy product beverages as well, calcium fortified one, you can meet your calcium intake. Okay, so now as I said, calcium absorption is inversely proportional to the need of the body. Okay, so if your body is deficient in calcium, you will be absorbing more calcium from the diet. If your body is sufficient in calcium and does not need any more calcium, you will be absorbing less calcium from the diet. Okay, so it is say need dependent. All right, now calcium supplementation. All right, so it is calcium carbonate is the most common form of calcium supplementation which is available in the general market. All right, so now with calcium supplementation, it is important to note that it is best to take calcium supplementation with food. Why? Because when your food is being digested in the stomach, you know hydrochloric acid is released, which is the gastric acidity. Okay, the acid which is released by the stomach to break down the food. And this acidic environment will favor calcium absorption. Of course, when you are having a mixed diet, you're also having certain amount of protein. The amino acids will also favor the absorption of calcium from the food. Okay, so more calcium will be bioavailable for taking into the blood. All right. So then with this is important, guys. So now with old age, the HCl which is released by your stomach, it may decrease with age, and therefore calcium carbonate supplements may not be as effective. So in this condition, it is good to have calcium citrate supplements, because citrate, that is the acidic part of it, all right, like vitamin C. So calcium citrate will increase calcium absorption from the supplement, because the acidic environment is supplied with the supplement in form of citrate. Okay, so yes, I hope that makes sense, guys. Then you have yes, supplements, it is best to be taking in, say, smaller doses, because it increases the absorption of calcium when you're taking it in smaller doses. So rather than taking 1000 milligram of calcium tablet, have say 500 milligram of calcium tablet, say during your lunch and with your dinner. That will increase your calcium absorption more. Okay, because it is dose dependent. Then you have yes, this is again very important, guys. Calcium is a mineral, as you know. Okay, it's a micronutrient. It is not like your water soluble electrolyte that you have extra of it and you will pee it off. No, when you're having a lot of calcium supplements and your diet is adequately nourished in calcium, this can increase the risk of calcification of your soft tissue. Okay, so then your heart, for example, is calcified and it cannot, the pumping action is impaired. Similarly, calcification of the other tissues which you have, or the other organs which you have, will compromise the functioning of those organs, which is not what you want. All right, so yeah, I hope that makes sense, guys. All right, and of course, when you have very, very high amount of calcium, this will hinder your phosphorus absorption. Okay, so it's vice versa. When you have high amount of phosphorus, it will hinder calcium absorption. Okay. All right, so now vitamin D, again, you know, vitamin D, very, very important. Why? Because vitamin D will increase the absorption of calcium from the intestine into the blood. All right, vitamin D has a role in, say, maintaining calcium homeostasis because it will increase the reabsorption of calcium from the kidney as well. All right. Then, yes, this is, again, most of you know about this, that groups that are high in risk of vitamin D, for example, conservative clothing, specific ethnic backgrounds, individuals staying at higher altitude because you have less sunlight. Okay. And then you have darker skin color, right? Because you have, say, less activation of calcium. All right. So, you will be, it would be interesting for you to know, guys. And I think I shared with you, I'm sorry if I shared with you and I'm repeating myself. Okay, that as I said in Canberra, the data set which we have regarding the pregnant women, they have around 60 to 70% of all women are vitamin D deficient. And as you know, with vitamin D deficiency, as you know, the functions, it has a big role to play with, say, reproduction and say, health in pregnancy and health of the child. So it can have a lot of adverse consequences during, say, labor, during childbirth and things like that. Okay, so yes, UV exposure index of 3 and above, okay, is required for sufficient amount of calcium to be activated and synthesized in your blood, all right, in your body. So now these are the months generally when you have, say, very less UV radiation, not enough to synthesize your, say, blood calcium level. So it says, say, for Canberra, for example, you have June and July, but I highly doubt because literally it is so cold over here, even if it's a nice sunny day, because it's so cold and most of the time it's windy, that you're generally covered in full clothing. All right, so for me, this UV ray really does not make a difference because I'm always covered in my jackets and being layered and being in office most of the time because of the teaching role. So all of these guys with vitamin D, there are so many, say, socio-ecological, environmental factors. They play a very big role in determining whether you're getting sufficient vitamin D levels or not. All right, so it is not just, yes, you have the UV radiation, but are you outside enough to get that UV radiation? All right. Okay, guys, now with phosphate, as you know, hydroxyapatite crystals, they are made up of calcium and phosphorus, all right? So now phosphate is naturally available in all of the foods. You don't really have phosphorus deficiency as such, okay? But the one thing which is there that, yes, phosphorus, for example, is high in milk also. And you have protein is also high in milk and calcium is also high in milk, which is making it such a complete food. All right, but your phosphorus is also very high in processed food. All right, which is not what you want, but yes, a lot of processed food which you eat, meaning a lot of phosphorus intake you're having. All right, so now with epidemiological studies, what has been seen that why do you have people who drink soft drink, they have poor bone health in the long run, is because a lot of dairy consumption is being substituted with soft drink. All right, not predominantly because of the phosphorus, but do be mindful that soft drinks, they have phosphoric acid as preservative, and phosphoric acid is your phosphate, okay, meaning you're having high level of phosphate if you're having a lot of soft drinks. All right, so now guys, what is the functioning of phosphorus? So now when you have high blood phosphorus level, okay, excessive amount of phosphorus in your blood, this will reduce the activation of vitamin D. And you know, when your vitamin D is not active, this will not trigger the absorption of calcium from the intestine into the blood. All right, so therefore your blood calcium level will be low. All right, so then the other thing which you have is when you have very, very high level of phosphorus, this will increase your calcium excretion in the urine. You know how it was opposite, I showed you in that diagram. All right, so similarly, when you have high phosphorus, then you have high calcium excretion in the urine. So again, what will happen? You will have low blood calcium level. Now when you have low blood calcium level, your thyroid hormone will be activated. All right, you will have a release of your parathyroid hormone. So basically, high phosphorus, it is causing secondary hyperparathyroidism, meaning you have hyperparathyroidism, meaning activation of your thyroid gland, of your thyroid hormone because of high phosphorus level. This is called as secondary hyperparathyroidism. All right, so now over here, now remember, when you have secondary hyperparathyroidism, the first thing the parathyroid hormone does is to tell vitamin D, go and get calcium from the intestine. But as you know, because of the high phosphorus level, your vitamin D, unfortunately, cannot be activated. All right, so this is creating a loop, meaning your parathyroid hormone is getting activated because the blood calcium level is low, but unfortunately vitamin D is not activated sufficiently, so it cannot increase the blood calcium level. So this keeps on staying in a loop, and the individual suffers from hyperparathyroidism. All right, so that is one of the reasons for hyperparathyroidism. All right, so now you have fluoride. With fluoride, lots of controversies around fluoride, and you have one of your presentation which is on fluoride as well, and we will learn a lot more in that presentation. Okay, but just as a brief say input into your lecture, you have fluoride. Yes, you have say fluoride where you have water which is being fortified with fluoride. Okay, so you have fluoridation of water. In New South Wales, the water is fluoridated with sodium fluoride, which is adding of just 1 milligram per liter. All right, so what does fluoride do? It helps in say strengthening of your teeth, your enamel. It increases osteoblastic bone formation cells. Okay, so these cells, they help in the calcification of the bone. They make the bone stronger. Okay, so it prevents say resorption of bones. So osteoblastic cells are good because it helps to say strengthen your bones, and it increases the other bone forming cells. Okay, so now excessive fluoridation, meaning when you have 2 to 4 milligram per liter. And this is what is seen in these specific say states across United States where you had sufficient level of fluoride in the water. They did not need to fluoridate it, but they added fluoride to the water, which made it excessive. This can lead to brittle bone disease, okay, which is called as crippling, say skeletal fluorosis. Okay, why? Because your hydroxyapatite crystals, they are now replaced by fluoroapatite crystals. All right, now these fluoroapatite crystals, they make the bone very brittle in nature, meaning when you have a fracture, guys, your bone may break into 2 pieces. Terrible fracture, it may break into 3 pieces, but at least it breaks like this where you can try to rejoin it. Now, when you have say brittle bone disease, basically bones are brittle, meaning when you have fracture with fluoroapatite crystals, it shatters into, like, you know how a glass shatters, it shatters into say 100 pieces, and it's so difficult or say practically impossible to get these bones rejoined. All right, so yes, that's why brittle bone disease, very, very scary. Okay, now guys, remember that when I talk about fluorosis, crippling skeletal fluorosis, this is different. You have a genetic condition for the brittle bone disease. Okay, I'm not talking about that condition. All right, you have a genetic condition why you may have brittle bone disease, and it may have nothing to do with fluoride. But you have similar shattering of bone, brittle bone in your crippling fluorosis as well. All right. So yes, your upper limit which you have for adults is 10 milligram per day. All right. So yes, excessive fluoridation, not at all advised. But yes, you need to have basic level of fluoride intake. Why? Because it has its own benefit with osteoblast formation, strengthening of your teeth enamel. So yes, it has important roles in your bone health. Okay, now you have your vitamin K. So vitamin K, basically, guys, it produces something which is called as osteocalcin. Now, osteocalcin is a bone protein. Think of it as a glue. Okay, so basically it is a glue which helps to stick the hydroxyapatite crystals in the bone. Therefore, it helps to strengthen the bone. All right, so yes, vitamin K helps in the production of the osteocalcin, this glue. All right. So now, guys, what happens when you have a lot of bone resorption, meaning calcium coming from your bone into the blood? This, what it causes is that it increases basically the osteocalcin level in the blood as well. Okay, because when you have say a bone resorption, you have release of the osteocalcin in the blood. So high osteocalcin level in the blood, meaning it is a sign of bone turnover, meaning bone resorption is happening. You have high level of bone resorption happening when you have high osteocalcin level in the blood. So it acts as a blood biomarker, okay, of your bone resorption levels. And as you know, vitamin K, yes, you have your green leafy vegetable, which is the primary source, okay, your greens. But also remember you have minaquinin, which is your vitamin K2, and which is what is synthesized by the bacteria in the large intestine. Okay, so you do have your human production synthesis of vitamin K as well. All right, then you have the anti-nutritional factors or say nutrients which hinder calcium absorption. So the first one being your fibers such as your oxalates and your phytates. Oxalates are present in your veggies such as your green leafy veggies like kale, spinach. Although they are high in calcium, they have high oxalate. Then you have your pulses and legumes. They are also high in calcium, but they have phytates. Now, this will hinder calcium absorption. Okay, so they are not the optimal source or the go-to source for calcium. Okay, your green leafy veggies and your pulses legumes, they have their own important, say, other nutrients, but not the best source for calcium. Then you have your tannins and your caffeine. This also hinders in your calcium absorption found in coffee and tea. Then you have high sodium. High sodium, just like high phosphorus, it increases calcium excretion. All right, then you have, for example, we learned about this in the hypertension sub-lecture which we had for your cardiovascular diseases, where have you have high sodium. So when you have high sodium intake, it will increase your calcium excretion. All right, then you have high alcohol intake. So basically, again, the issue with alcohol is like the issue which you have with soft drinks. At an epidemiological level, studies have shown that when you have high alcohol, this will replace your dairy in the diet, okay, and therefore this is associated with osteoporosis, okay. And of course, as you know, with alcohol, it hampers a lot of other nutrient absorption as well. All right, then you have your isoflavones. So isoflavones are good. That's why I have kept it in green in color. So isoflavones, they are present in soybean. They mimic estrogen. All right, so basically estrogen for women, as long as women are menstruating, they have high estrogen level. And estrogen increases your calcium absorption retention in the bone. All right, it prevents calcium resorption of bones. All right, so isoflavone is the same thing. It inhibits calcium resorption from the bones. All right, so also isoflavone is good. All right. Then you have a theory, guys, which is called as acid alkaline diets. Okay, so again, as I said, there are a couple of theories, not sufficient evidence to prove this as, say, a point. Okay, so now what is high acidic diet? I briefly spoke about it. A high acidic diet, guys, it will increase your renal acidic load. It will increase the acidic pH of your urine, and it will lower the acid. It will lower your blood pH, meaning it will make your blood pH more acidic in nature. Now, this is your normal pH of your blood. You see my mouse over here hovering? Okay, this is the blood normal pH. So when your pH is less than 7.35, this is called as your blood having an acidic pH. All right, acidosis. All right. So now, guys, I don't know why today my nose is so itchy for some reason, but don't worry, that is not a sign or symptom of coronavirus. Okay, it's just itchy. Sometimes I just get so itchy on my nose for some reason. Anyways, okay, so that's why you will see me going a lot like this in the lecture today, because I don't know why it's itchy for some reason. Okay, basically there are cultural sayings. So I think in my culture, when your nose is itchy or something, it's likely that you have guests coming to your place or something. So I should be expecting guests coming to my place, I think. So yeah, we have these funny things in my culture. So maybe it's one of those signs. Anyways, sorry, getting back to the point. Okay, so yes, guys, when you have a high acidic diet, it increases your renal acidic load, all right? Increases the, say, acidic pH of your urine. It increases the, say, it makes your blood more acidic in nature. Now, as you know, all of this acidity conclusively causes what? It increases the calcium excretion from the urine. Okay, whereas an alkaline pH, now your H plus ions, they are an indicator of the acidic pH. All right, so your OH minus ion, they are an indicator of alkaline. All right, so now with alkaline diets, basically it decreases the renal acidic load. It normalizes your urinary say pH. It normalizes your blood pH. See, over your alkaline diet, it's not saying that it makes your blood pH more basic in nature. Okay, so it's not that you have alkalosis happening. All right, so alkaline diet, it helps to bring the pH back to normal. All right, so yes, when your blood pH is normal, when your urinary pH is normal, when your kidneys are not taxed, meaning what do I mean when they are not taxed, meaning when they don't have a high acidic load of the kidney, this will decrease your calcium excretion. All right, so this is what an acidic, and therefore you have these diets which are called as acidic ash diet, basic ash diet, and therefore you have dietitians, nutritionists who are recommending to have a basic ash diet, all right, because it is less taxing for the kidney. All right, but as I said, this is still a theory, guys. It is still a school of thought. It is not 100%. The evidence is not proven. All right, so now, guys, what are the sources of your, say, acidic and basic foods? So you have animal proteins like all of your red meat, white meat, and cheese. These are considered as your acidic food. Then you have your moderate to mild acidic foods. These are all of your, say, vegetarian protein, like your pulses, legumes, and even your cereals and things like that. All right, then you have your alkaline foods, which are all of your fruits, veggies, and your spices as well. Okay, and then you have your neutral foods. So neutral, not contributing to acidity or alkalinity. All right, these are your milk, sugar, honey, water, butter, oils. All right, so as I said, guys, this has more of a naturopathic science approach. But yes, the nutrition science has sort of not thrown this away. It is sort of acknowledging it, but it is requesting more evidence, as I said, only because nutrition science does understand that your renal acidic load can increase. There is a thing such as renal acidic load. When you're having a lot of protein, this does tax your kidney. For example, when I said when you're having 3 to 4 kilogram per kg body weight of protein, this is taxing your kidney. Okay, because your the amount of ammonia which you need to excrete in your urine increases. All right, so yes, that science is definitely there, but to prove acidic and basic ash diet, this still needs further investigation. But it is good for you to be mindful about this, because you have so many clients say sharing this and saying, oh, is my diet causing acidic ash, basic dash? So you should be aware of these concepts. Okay. All right. So yes, as you can see, this again is not a very big lecture. So yes, I have been good. All right. So now, guys, week 8, of course, it's mid-semester break. You do not have any lecture or tutorial. But please note, week 9 is your mid-semester exam. So your mid-semester exam, it has all of your content right from week 1 to week 7. All right. So till this lecture. All right. So all of your lecture and tutorial content. Now, please remember, because I get this asked so many times, in the final exam, do we have all of the content which is covered before the mid-semester break? Yes, you do. Because after the mid-semester break, guys, we only have 2 lectures which are part of your accessible units. All right. So you can't have a final exam with just 2 new lectures. All right. So that's why final exam will have everything which is right from week 1 to week 11. But remember, in your final exam, you have already covered everything from week 1 to week 7. Week 8 was mid-semester break. Week 9 was your final exam. So week 10 and 11 are only the 2 new lectures that you will be studying for your final exam. Everything else is going to be a revision. That's why I have seen the trend which has been in the last 3 years. Students do very well in this unit. Why? Because they have so many opportunities of revision. Till now, all of your tutorials are a lot of revision. And so is your final exam. Why? Because mid-semester exam is, say, a revision for your final exam. Okay, so yes, it will go well, don't worry. All right, and yes, this week, week 7, we again have oral presentations in our tutorial, face-to-face tutorials. Okay, so I'll be seeing you for your oral presentation. And under nutrition lecture is super duper simple. I do not have any, say, MCQs for that, the Kahoot quiz, but definitely bone health requires the Kahoot quiz sort of a revision. Therefore, I'll be providing you with Kahoot quiz and self-study question for your bone health lecture. So I'll be having those PowerPoints in your canvas that you can do in your own time. So yes, please, for your for your mid-semester exams, do revise your Kahoot quizzes, because you never know, hint, hint, you may have a few things from your Kahoot quiz questions come into your multiple choice in your mid-semester or your final exam. So your Kahoot quiz is not a waste, okay? You're actually, each tutorial, you're actually studying for your exams. So all of your unit has been designed in such a way to support your final and your mid-semester exams. Okay, guys, that's it from my end. And I'll see you very soon in the tutorials. Okay, so see you soon.